Hello. Can you hear me, guys? चलो ऑन कर दो नो so hello guys. Hi. Can you hear me? All right. My voice, video, everything clear? Let me see. Great. So just right. Okay, guys. So let's start our session. Already we are late. So without wasting any further much time, let's start today's session. Okay. All right. So tell me, guys, is my screen visible to you? Can you see my screen? Good evening, OS. Very good evening. All right, guys. So let's start today's session without any further much wasting our time. So, before moving forward today's session, let's recap what we have learned on our last session. So, on the last session, we talk about microcontroller. We start with microcontroller. We understood that how microcontroller works, how microcontroller act like a brain for digital, electronics or robotics, right? So basically what microcontrollers does is it thinks and processes all the commands or instructions in order to give you particular output. Okay. Or it can be used as to get input from the user and give a output based on the input, right? So it's basically work as a brain for a robot in robotics, right? And if we talk about circuit, so circuit is basically, you know, how we interface each components of electronics. For example, if we are interfacing a LED, push button or any other electronics component, a sensor or anything, servo motor. So that comes into the circuit. Okay. And, the most important thing in a circuit is the breadboard. Okay, so as a beginner, you should know what is a breadboard, how the breadboard works, and I'm going to show you how it's worked basically. So let's start, guys. Let me check out some comments. Yeah. Okay, guys. So if you are ready, so let me see the thumbs ups. All right, show me the thumbs ups. Show me the thumbs up, guys, if you are ready for the session. Come on, come on, come on. Yeah. All right. Amazing. Let's move forward. And as we have discussed that we called microcontroller as the brain, but what, like exactly why we call the microcontroller as the brain? Okay. So just similar to our brain gives our body the instruction that we have to walk, we have to eat, we are feeling hungry, we want to sing, we want to dance. So it's just like that. Okay. So, you know, for our case, we are using Pictoblox or Bookwe for our starting point, right? So we are using Pictoblox in order to visualize the code. like building with Legos, right? So you have in childhood you might have played with Legos where you build some buildings or some kind of games or some kind of car or anything with Legos, right? So it's just like Lego blocks, you connect each other and then you build your code, right? So it's a perfect learning logic without, worrying about the syntax, the text error, without worrying about coding, right? And then we are simulating with WorkV without the need of real hardware components. But yeah, I have seen many of you are not having computer. Uh, yeah, but sadly, the thing is, Pictoblox, the software only works with PC. It doesn't support in your phone. So I would suggest borrow some of your friends' laptop and try it to understand how it's work. Although we will be learning how to get codes using AI tools in our last uh, lecture, most probably. So just stay with the sessions, do the assessment. You're gonna learn a lot of things, all right? And in the next session onward, we will be learning C++ or the actual language we need to know in order to work with Arduino, all right? So that's our goal. Now, one point which we missed in our last session, that is about register. So we learned how to interface LED with Arduino, but we have missed one thing, that is resistance. All right. Now, why resistance is important? Let me show you. Let's say, you know, so yeah. All right. Okay. So, as you can see here I'm having a LED. All right. So I think my screen is visible. All right. So I'm having this LED, right? Now this LED is working only if we are providing it a voltage under 5 volt, right? So can you imagine what will happen if I provide this LED 6 to 7 volt? Okay. What will it happen? Let me see the chat. Okay. Tell me that if this LED works with just 5 volt and I'm providing it with 6 or 7 volt, what will happen? Definitely. It gonna burn out, right? So the LED gonna burn out and we will be losing our LED, right? Or, I'm giving you this small example of LED, but in digital electronics, for example, if your computer, if your laptop you're using, then it's having, thousands of components in one circuit board. Now imagine if one component fails, the entire computer will stop working, right? So if you ever see a motherboard, the components inside those motherboard, they are all connected with resistors, right? So definitely, whenever you are interfacing a LED, you should also include a resistance in order to create a barrier between, the power supply and your LED. All right. So what happens in a microcontroller is, for example, whenever I'm having this microcontroller, right, the Arduino, the power output, which is says that it gives you 5 voltage, but it's not always 5 voltage. All right. So it's fluctuate. Sometimes it's 5 voltage, sometimes it's 4.7 voltage, sometimes it becomes 6 voltage. So on that case, what happens is whenever there is a variance in uh, current or voltage, our LED or any other electronics component may get damaged. All right. So that reason it's becomes very necessary. So whenever you are, working with LED, it's a good habit to, include a resistance. Although if you don't use resistance, the circuit gonna work. That's gonna perfectly gonna work without any problem. But yeah, exactly, it's gonna burst, right? So, but even without resistance, it works. But the good practice is always use resistance. And how to use it? You have to use it in series. Okay, you know about series connection, parallel connection, right? And also, before moving to our next session, I will, next topic, let me again explain you in detail how the breadboard works. All right. So, in this breadboard, you can see, how this all holes are present, right? So we are having holes which are, some of the holes are parallel. Okay. So the topmost hole you can see, these are parallel, right? But uh, I think the camera is not working properly. Or can you see? All right. Take team, can you like tell me it's blurred, right? Okay. Camera is having some issue. No, otherwise stream will be working. All right. So yeah. Uh, I guess you can see, right? Let me just, let me show you with the help of my, yeah, I guess you can see, right? So here in this breadboard, you can see some of the holes are parallel, right? They are parallel, which means they are connected parallel. Okay. And some of the holes are connected, uh, in the form of series, you can say. They are horizontally connected. So these holes which are in the middle, they are basically horizontally connected with each other. For example, in this, row, the entire row is connected. Okay. Internally they are connected. So if you put something in this hole and in the, this hole, they all will be connected or short circuit, right? Similarly, for all the holes present here, they all are connected in, horizontal. But on the other hand, if you talk about this corner side holes, they all are connected vertically. Okay. So they are not connected horizontally. For example, if you talk about this hole and this hole, they are not connected. But all the holes which are horizontal to this are connected with each other. All right. So this is how the breadboard works, and this is how we interface everything in the breadboard. For example, if you want to put LED in, if you put this LED like this, can you tell me what will happen? If you interface this LED, what's going to happen? Yes, you're correct. So, yes, so if I put the LED like this, it will short, right? It will short circuit because this horizontal, they are horizontally connected, right? So we should not put our LED like this in a breadboard. We always have to make sure that whenever we are interfacing a LED in a breadboard, it should be like this. The both legs should be in a different row. Okay. So this is how we interface LED in a breadboard. All right. So yeah, I did it. Now we will be talking about our next topic, which is about push button. All right. So if you see, this is called a push button. Okay. Now this push button is having four pins. All right. So I'm sorry. So this four pins may confuse you. Okay. It may confuse you like, how can I interface all the four pins in a circuit? The switch must have only two pins, right? So we know how switch work. Switch is basically a circuit which used to, close or open a digital circuit, right? So this is also works in the same way, and you don't need to use all the four pins. Okay, you just need to use any of the two pins, and I mean any of the alternate two pins. For example, if you are taking this one, okay, then you have to take this one or this one. Okay, so if you are taking the pin, one pin here, you have to take it here, right? If you are taking one pin here, you have to take it here, right? So it's basically connected in the form of cross, you can say. So if you are taking this pin, okay, then you have to take another pin as this one. All right. And if you're taking this pin, you have to take another pin as this one. All right. So I hope it's clear. And how to interface it in this breadboard is, you just have to find the middle portion of this breadboard. Okay. And you have to make sure that two pins are connecting with this one, right? And another two pins is on this side, right? So you have to just push it a little bit, and you have to make sure that you are not damaging the pins. And yeah, this is how you can connect, the switch, you know, breadboard. All right, got it? Great. Now, uh, all right. So now move to our station. Yeah. Okay. So that is about connecting breadboard. All right. Now let's have a clear, detailed discussion about Pictoblox, how to work with Pictoblox, okay, and how you can, uh, you know, how you can, work with Pictoblox. How, what are the terms? What are the things in the Pictoblox? All right. So let me share you my screen with and show you the Pictoblox screen. Just a minute, guys. Yeah. Yeah, it's working. Now let me just share you. All right, guys. So I guess you can see my screen, right? So here I am into Pictoblox. All right. So in this Pictoblox, you have to select the block coding option where you will be getting the option of blocks, right? So if you just click on here, you will be coming into this interface, which looks more of a like a Scratch interface. So it's basically the Scratch, but here is a different thing. Like if you have installed that particular, Pictoblox, which I have given you the link of, you will be able to find that once you install it, you will get this option of boards, right? So here you have to just click on the board, uh, whichever board you want to work with. All right. So if I want to work with Arduino Uno, let's click on Arduino Uno. Right now, no device found because I haven't connected my, this Arduino with my laptop or PC. So I will just close it. And this is the stage where you can animate. We can, basically move this cartoon character, move 10 step, turn it, clockwise, anti-clockwise. You can glide it. Okay. So these are the things which kids usually do, but we are not kids. Right? So right now, what we will do is once we are, click on this board, we have selected Arduino Uno. Now we have to go to this mode option. Okay. So here in this mode, you will be able to find two options. One is, stage. One is upload. So just click on the upload and you will be coming to the interface where you can work with Arduino, right? All right. Uh, I think there is no network issue. I can see my video streaming live. So please check your internet also. Uh, yeah, maybe sometime it's becomes buffery or internet becomes slow. Uh, please try to understand, right? All right. Now, in order to code with Arduino, we have to first understand the Pictoblox, all right? How is it working and all those things. So I want to share you the screen. So here in the slide, you can see, uh, yeah, amazing. So now you can see in the Pictoblox, we are having four things, all right? What are those four things? First is the palette. Okay. Now, what is palette? It basically all the options where you are having the blocks. So this is known as the palette or the blocks palette. Okay, so here you are having control palettes, block, operators, variable, your blocks or Arduino, actuators, sensors, display. We will be discussing about each and everything in detail, right? So no need to worry about that. And if we move forward and we want to see what next is, so we are having a script area or the center space or your workspace where you will be, dragging and dropping all the, blocks here, right? So if I'm dragging this block, so this is my workspace. Okay. And uh, this is the center space or the building block space where you will be building your own codes, right? And on the right side you are having the stage, all right? Although we don't require stage, but for us the stage will be showing us a live preview of the codes. Okay, so if we are writing a code, it will show us the C++ corresponding codes, all right? So whatever blocks we are, creating, joining here, it will showcase it in the form of codes. Now, let's move forward and yeah, it's about the extension. Okay, so as we are using Pictoblox blocks extension. So we are having a extension of Arduino Uno. Okay, so as you can see, when Arduino Uno starts, okay, so this block we are having because we have selected the board. Okay, so if we have selected some other board, we will be getting some other, things. All right, so it's about the user interface of the Pictoblox. Uh, Now let's talk about what about these blocks are. What are these blocks and how these blocks works? So the first, set of blocks in the palette is our control palette. Okay. Now this control palette, by its name, we can understand it helps you to control the circuit. Okay. So to control your programs, to control your, instructions. Okay. So if I would have to tell you how it's all is happening, the first block, it's about weight. So weight means what? It makes you wait, right? Or in terms of Arduino electronics, we call it delay. Okay. So in a circuit, if we want that our LEDs would blink after 1 second, every 1 second, right? So we use this wait block. Okay. And we can select how much time we want to delay our circuit. So if we are clicking it, like we are, setting it for 4, it will delay our circuit by 4 seconds. If we are putting 1 here, so it will delay our circuit by 1 second. Right. Next, we are having repeat. It means, for example, if I am putting something in between, so it will repeat this particular instruction 10 times. Okay. And after that, it will stop repeating. Okay. So it will uh, 10 times run this code which is in between this block. Okay. So you can put anything in between. For example, if you want to, put this thing in between, so it will run this particular block of code 10 times. And after that, it will stop. All right. Now, similarly, we are having forever. Okay. So the difference between this repeat and forever is that repeat works for a particular period of time. Uh, how much time we want our program to run, it will run. If we want our program to run for 30 times, it will run it for 30 times. If we want to run it for 5 times, it will run it for 5 times. But in the forever, what happens is it runs forever. Okay, so until and unless you turn it off, it runs forever. All right. So uh, if I have something like that, control, and for example, if I want to read the analog pin or read the status of digital pin, uh, if I'm using this pin, right? So what's happening that in the forever loop, this particular block of code is running forever until and unless we are manually stopping the circuit, right? So this is the work of forever loop. And next, we are having count, right? So it's basically counts I. So it will be counting a variable as you can choose any of the variable. What our variable is basically it's varies, right? So we can vary something in a code that's called variable. So for example, it says how many apple you are having. So you will say, okay, I'm having 0 apples right now. But if I give you 10 apples, how many apples you are having right now? You are having 10 apples, right? So apple is the variable where before I give you the apple, it was 0. Once I give you, it's became 10. And once you give 5 apples to someone else, it becomes 5, right? So variable is basically something which varies and we can make it vary. So we can, use this particular block of code in order to vary the variables from 1 to 4. Okay. So each repetition, it will increment it by 1. For example, if I want to execute this code, this block of code inside this, what will happen? Uh, First, it will be 0, I equals to 1. Okay. And then it will set the PW pin 3 as output this, whatever this block says, right? After which, what happened? It will again come to this section and again, now my I will be 2. Okay. And then it will again run this code and it will increase my how, for example, uh, if my switch is on, then only I want my LED to be turned on. Okay. So if I want to make that logic in a code, I have to use the if then block. All right. Is it clear? Uh, Tell me, guys, is it is it okay, or are you getting bored, or are you understanding, or everything going just fly by from your head? So just let me know once. Are you guys getting it? What I'm explaining to you about each blocks, because it's very important in order to understand. Let me know. All right. What do you mean by manually stopping? Okay, manually stopping means you are just pulling the battery off, okay, or you are just switching off your circuit. That's what I mean. Okay. So manually stopping means just pull out the pins, pull out the wires or the connections, and your uh, circuit stops working. That is what I mean basically about manually stopping. Uh, all right. Now let's talk about operators. Like, I think you know about this if then and if else statements. So then we are having this block which says if and else. So if I say that if my switch is on, then only I need my LED to glow. But what about if my switch is not on? Then we use this block which says if my switch is on, then my LED will be turning on, right? But if my switch is not on, my LED will turn off. Okay, got it? So that is all about if and if else, right? Now, we are many other blocks we are having, but it's better to learn about this by doing stuff rather telling you how this works in detail, all those things. Just for basic understanding, I'm going to tell you that this is all about the control palettes, okay, where we will be getting all the blocks which helps us to control our digital logic which we want to implement in our project, right? Next, we are having the operators. Now, what this operator does. So, you guys are aware of what is operator, right? So, it's not something which is very, out of the planet sometimes of terminology. It's operator. Basically, it's plus, minus, division, or greater than, less than. That's the thing. Sir, I did blinking LED using push button, but the LED is blinking without turning on push button. I don't know what mistake I made. Okay, definitely we're gonna see that what kind of mistake you have done in our today's session. Uh, Definitely, I'm gonna tell you what mistake you made. That's a very common mistake. It's about the push button. How we are interfacing that push button depends on that. Whether our push button is working or not. It's very simple, but it's very easy to mistake on that particular topic. All right, so now we will be talking about the operators. Okay, so these are basically the operators where we are having addition, like subtraction, we are having multiplication, then we are having division, then we are having pick random 1 to 10. So if we want in some of where we need to have some random numbers, right, then we can use this blocks, right? And this thing is very important, okay, which is about mathematical operation like greater than, less than, or equal to. So if we have to check some conditions, so whether I have to, for example, if I have to check whether my button is turned on or not, and we have to use this particular operator, which is greater than equals to or equals to, like this. So if my button state is equals to, you know, 1, or I mean, if my button is turned on, then what I will do is I will do my other stuff. I will make my LED glow, right? All right. Then we are having some other blocks which are and, or, not. So I think you guys are well aware of these things. I'm not gonna go much deeper. And is basically it's compare both the statement. If the both the statement are true, then only it passes true, right? And or what happens if one of the statement is true, then it will give the final output as true. And not, basically it's turn all the logics opposite. If we are having true, it's became false. If we are having one, it's became zero, right? So that's basically what operator does. Now talking about variables. Now, as I have explained to you what variable is, Variable is something in a code which can be varied. Okay. So which can be varied means which can be changed, which can be updated. For example, if I am setting, yes, logic gate. So it's basically logic gate operation of and or not. And if I'm talking about variable now, this variable is basically something which can be changed. For example, right now you're having 0 apples, but if I give you 10 apple, you will be having 10 apples. Okay. Then if you give 3 apples to your friend, you will be having 7 apples remaining with you. So this is what very basically variable is, coding language. All right. So we need variable for many purpose, for various purpose in the code we will be seeing in our upcoming activities. All right. So now if you have to make your own variable, you just have to click here. All right. You can name your variable whichever you want. The condition is it should not be starting with a number. All right. So yeah. Now if I just name one of my variable as LED LED state. All right. Okay. All right. So this is my LED state, right? So in our case, we will be checking what is the state of our LED, whether whether our LED is turned on or our LED is not turned on. So we can check it using this LED state variable. Okay, and it can be changed. So as we know that variable can be changed, that means we can change our button state. So sorry, the LED state we can change if our LED is turned on, we can change it to turn off, right? We will see how we can do it. And then we can see in the variable, we are having some blocks, right? So here, if I choose this block, here you can select whichever variable you want, right? So if I just click on this variable, what it will do is will set my this LED state variable to 0. All right. Okay. And if I turn it on by 1, so what it will do is it will set my LED state variable to 1. Okay. Got it. So that's basically what we do. And if we want to change or update our variable, we can again select our variable and we can say that updated by 5. So it will change my variable, which is previously set to 1 into 5. Okay. So this is about the LED state, right? Got it. Now, if we talk about, what other things are there. So now we move to our main blocks. That is about, Arduino. Let me just clear all those blocks. I'm just explaining each and every block to you just to make sure that you can try it by yourself. You can explore it by yourself, right? Uh, Within just 1.3 hours, it's not possible to teach you everything. But I want to make sure that I will give you the idea of everything so that you can explore it and learn it by your own. Okay. I can show you the path, but you only have to work on it, right? And also, guys, I like your creativity that more than 15 students have submitted the same screenshots. Uh, I'm not going to take your name, but see, the thing is, we are providing this workshop and we are providing this lecture, we are providing this assessment just because of you, to give it to you for your own benefit. You have to make sure that you are doing it sincerely. I'm checking each and every response. I'm checking each and everyone's progress. So let me see, guys, how you are responding. And it's not like that. It's something very difficult. Everyone is doing. Okay. If 10 people are not able to do it, 90 people are able to do it. It means that those 10 people are not putting that much effort. So put that effort. You can do it. Everyone can do it. Okay. There is nothing called impossible if you just try and try. All right. Once See, I have seen few people that telling me like, "Sir, I'm not having laptop. I'm using my phone. How can I do it?" And even I have seen some of the people have executed, the activity in WorkView in their phone browser. So that is what dedication means. I really, like that. Your dedication is the only thing which gonna make you successful, not how much grades you are getting, how much score you're getting. That doesn't matter. Okay, and I'm here to see how much efforts you are putting. Okay, if you are putting efforts, you win my heart. All right. So yeah, what if we don't have Instagram? It's fine. Then you can follow the Savishkar in LinkedIn, I guess. We are having LinkedIn profile also. So maybe you are a professional person, you don't have Instagram, that's fine. You can follow it on LinkedIn, right? So yeah, now let's talk about our Arduino palettes. So what we are having in Arduino. Can I submit it now after this lecture? Yeah, I guess the from assignment form is still open. It will be open for 1 or 2 days more. Uh, you can submit it in between that days. All right. So now we are having our Arduino where we are having this block. This is the main block which defines that we have started our code. Okay. So your first job to start with Pictoblox is to grab and pull this block into your stage right here. Then you have to start your coding. Right now, let me explain you about some more thing. That is about read or set digital pin 13. We are having total 13 pins in our Arduino, right? So if we are having 13 pins, we can select any of the pins. Okay, we can select any of the 13 digital pins. All right, and you know you can just what do you say? You can just set it as high or low, which means whenever you are setting the pin number 7 as high, it means if you are connecting any circuit with it, okay, if you are connecting any circuit with it, the circuit will be closed. Okay, a current will be flowing through that circuit. All right. So as I have said in our last session also, that the digital pins act like in if we are using it as an output pin, it acts like positive terminal, right? So whenever we are interfacing a LED with it, we have to interface the positive terminal of it with the digital pin and the negative terminal of it with the GND pin. All right. So that's basically how it's worked. And now, if I need to tell you how it's you know working, then I have to show some other pins. Like if I'm using this block, what does it mean? Okay, so this blocks means it's read my digital pin as a input. For example, if I'm interfacing a push button, I have to check everything in the binary form. For example, if our circuit is closed, we define it as 1. If our circuit is open or where the current is not flowing, we define it as 0. All right. So we have to read our pins. Then what will this reading will give you? It will give you either 0 or 1. Okay. So 0 means it connected. Sorry, it's not connected, and 1 means it's connected. Right. So this is how we can read our digital pins. Yeah, this is about the blocks which we require right now. Although we will be moving towards this actuators where we will be controlling our, the servo motors and, this motors using those pins, right? Using this, actuator palettes. Then we will be having our sensors where we'll be able to sense, the distance between objects. We can able to, initialize some LED screen or LED display. And these are some other features. We will be talking about it. But let's focus on today's our motto. So this is all about a detailed instruction about Pictoblox. I hope it's pretty much clear about Pictoblox right now. So you're having some idea about Pictoblox, like you can work with Pictoblox. Show me a thumbs up, guys. Let me see the thumbs up in the chat box. Come on, fast, fast. Come on, come on. Yeah, that's my boy. Clean. Many of you have just take the screenshot of the output shoot which you got from ChatGPT or any Gemini, and then you have uploaded and you thought that sir will be not checking and we will be getting the marks. So not that that's not gonna work. But yeah, I would say I would congratulate to those people who have scored 10 out of 10. They have, you know, uh, they completed that task or that hands-on activity, you know, perfectly uh, using the, Pictoblocks and the code, the WorkV software. So that's amazing, guys. And today we will be talking about how to interface two LEDs with real Arduino. All right. So we will be seeing it how to turn on two LEDs alternatively, just like a traffic signal. For example, if we just for simplicity, if we take just two signal, one is red, one is green. So red means traffic need to stop. Green means traffic need to, you know, they can go, they can fly. Okay. So that's basically two LEDs which we need. And first we will simulate it, and then we will be moving forward how to, interface it with the Arduino. And next topic will be our how to interface a button, right? So we will be interfacing button next. All right. So let's do it, guys. And if you can do it together with me, it's amazing. All right. So let's start with the code. As we know, we have to first choose a board, Arduino board, right? Then we have to go to if you will be default, your default view will be in the stage. You have to change it to upload. Once you are in the upload, what you have to do, you have to just grab this particular block, pull it in the middle of your screen, and then you're done. No. Okay, someone is having question. So can we do coding in Pictoblox without using an actual Arduino Uno? I don't have Arduino Uno board, so don't didn't do that Pictoblox coding. You don't require Arduino in order to start coding with Pictoblox. We are introducing Pictoblox and WorkV just because I am assuming that no one is having hardware, this hardware or Arduino Uno or Arduino, anything you are not having, I'm assuming, right? So you just have to install it. You can find the link of this software in the description of this video. You can just click on that link. You can download it as per your operating system. And once it's installed, you can start working with it. You just have to select Arduino Uno and then it's done. You don't need to have a real Arduino, right? So once you just grab it here, next thing is to make sure your LED is running continuously, right? So for that link or repetitively. So if I use this block, you know, so what will happen? My signal or my traffic signal, which I'm making with one red and one green LED, I want the LED to first, I want that when my red LED is turning on, my green LED should be turned off. Okay. And then when my green LED is turned on, I want my red LED to turn off. All right. So that's how a signal works. Right. So for that, what I need two digital pins in order to control two LEDs. So the number of LEDs you want to control, you need that number of LED pins. Okay. So in this Arduino board, you are having 13 digital pin, right? So you can integrate 13 individual LED pins, okay, or you can control 13 individual LEDs. So you can control up to 13 individual LEDs. Can you imagine? So for our case, we are using just two LEDs. One is red, one is green. All right. Yes, you are correct. The whole point of using walkway is that we don't require hardware. Yes. So right now we just need two digital pins in order to interface two LEDs. So what we will do, we will go to Arduino Uno palette. We will find this thing. Set the digital pin 13 as high. Okay. Now what it will do is it will basically set your whatever pin. Let's choose the pin number 3 for the first LED for the red LED say, and I want it to be high. Okay, and then I again bring this block, but now I'm having the fourth digital pin. Okay, so I'm using the digital pin 3 and 4 in order to interface to LED. All right. So you can use any of the pins. It's up to you. All right. So I'm just taking for simplicity the pin number 3 and pin number 4. So what I want is I want that if my red light is turned on, okay, my green light should turn off. Okay, so if my digital pin 3 is depicting red light and it's turned on or it's in the high state, right? So I want my my green LED to be low. Is it clear? Is it clear? So the moment I'm having the red light, all the other LEDs are turned off in a traffic light, right? So similarly, if my red light is turning on, the green light is turning off, right? So that's why I have kept it low. All right. Now, as I discussed about the control, we can delay using this wait block, right? So if I want to make sure that the red light is for say 5 seconds, right? Uh, then what will happen? See, basically, how this block coding works is it works step by step execution. So whenever I am executing this code, what's happen is first this line of code will execute, then this line of code will execute, then this line of code will execute, and then this line of code will execute, and then this line of code execute. But if I'm not having this, repeat block, what will happen? Our code will run for just one time and it will stop working. Okay. So it will set my digital pin as high, then it will set my digital pin 4 as low, and then it will wait for 5 seconds and done. It will do nothing else. Right. But if I'm using this repeat block, then after executing this block, it will again come to this block and start executing the same thing all over again. Till how much? Till tens times. Okay, so it will repeat it by 10 times. Or if I reduce it by 3, it will repeat it by 3 times and then it will stop. Okay. Next, if now our first condition has been done. When we want that our LED, our red signal is turned on, so our green signal is turned off. Okay. And then we wait for 5 seconds. And after 5 seconds, our signal will be interchanged. Our signal will be green. Our green LED will be turning on, and red LED will be turned off. Right. So what you have to do? You have to just again grab this block, these two blocks. Okay. Now change it as 3 and 4. Now I want my red LED to be low and my green LED to be high or to be turned off, right? That's it. That's the code you need, all right? That's the code you need, okay? Uh, Now, if you see just beside it, you will get the C++ code, which we need to, use in order to work with Arduino, right? So in the C++ code, you can see the corresponding code has been written. So here we are having two basic function, void setup and void loop. So in the setup, what we are doing is we are setting the pin. We are setting the pins which we need to interface, right? So our first pin is pin number digital pin 3. Okay. So we just use this function pin mode 3 and we set it as output. Okay. So we are giving output to the LED. Okay. We are not taking any input. Okay. So we are just giving the output to the LED in terms of voltage, right? So we are setting up one LED. This is our setting of two LED. And this for loop is basically this repeat block, okay, which repeats our execution 10 times. All right. So it repeats our execution 10 times. And then we use this digital write. So this block basically means digital write the pin number 3 as true. True means what? It's high. It makes the circuit high. And if it's false, it means our LED is turned off or the current is not flowing into that circuit. All right. So I hope it's pretty much clear. Now what you have to do is just simply copy this code which you are getting in this console. Just copy it and then move towards, yeah, just let me give me some time, guys. I guess okay. Yeah. Swam my means to. All right. So, okay. All right. So now I will show you how we can, you know, just give me a second. Let me go to workweek, or better, I can show you. Yeah, I think you can see, right? So I'm going to workweek. Okay. So if you just search workweek in your browser, you will get this link. Just click on it and you can simulate any of the Arduino microcontroller you want, right? So here you just have to select this Arduino Uno, scroll down, go to Arduino Uno, and here is your simulation. All right. Now you just have to copy and paste the code which you got from your Pictoblox. I mean this one, right? So now what you have to do is just go to the workfree. Now, as we have discussed, we need two LEDs. So I will bring two LEDs. Let me scroll it down. So I am taking two LEDs, one red, and again I'm taking one LED and I'm taking it as green LED, right? So we are having green LED and red LED. And now we need a breadboard, right? So I'm taking one half breadboard. Now in this breadboard, what I will do is I will just simply put this LED here. So you can see if I zoom in, right? So I have chosen this row and this row for this LED, right? Now I'm taking another LED, which is this, right? So you can see now this LED is connected with this row and this LED pin is connected with this row. All right, it's fine. Now, as we have discussed, we need resistance also in order to make sure our LED doesn't burn out. All right. So I will just turn it, and what I will do is, I think it's fine. Yeah. So here, let me just pull it some here. Yeah. Great. Now, what we need to do is, for the positive terminal, we have to connect it first with the resistance. All right. So as you can see, this is our positive terminal of the LED, and we are connecting it with the resistance, right? Next, we need another resistance, and we are again connecting it with the positive terminal of this LED. All right. Now, what we are doing is, we need to do the connections, right? So, as we have discussed, that pin number 3 is our for red LED, right? So this is pin number. So this LED's positive terminal going to set up with the pin number 3 of this Arduino, right? So let's take the pin number 3, extend it, and let's pull it, and let's connect it with here. So let me make you the circuit clear. How? What's happening? I am first connecting the positive terminal of the LEDs with this resistor, right? And I have discussed all the rows are connected. So here, this LED's positive pin is connected with this resistor, all right? So once this is connected with this resistor, and the other end of this resistor is connected with the digital pin 3, right? So this is the connection. Now for the second LED, so how to know how much of your resistor to use for some its voltage using Ohm's law? Uh, you really don't need to use Ohm's law here. It's better to use a very low resistance for your, if you are interfacing this just LED. Uh, just 1K of resistance is fine. You don't need more resistance, because the LED works fine without resistance. You are just keeping it for just safety, right? And if you want to increase the resistance, the cost of that resistor gonna be higher than this, right? So just 1 kilo ohm resistance is fine for interfacing LEDs, right? Now the second LED, the green LED, we want to connect it with the digital pin 4, right? So what I will do is, I will just extend this, and I will connect it with the pin number 4. Okay. Now, are we done? No. We have just connected the positive terminals, right? Now, what about the negative terminal? Now, let me show you something useful in the breadboard. As you can see here, we are having this positive and negative mark shown up, right? So, what we can do is, we can take the ground common. This is the ground, right? We can take the ground common and connect it here. All right. Are you getting it? So we are just taking the ground common from here, and we are taking we are putting it here in this plate hole. So what will happen is, all these holes which you can see, I am pointing this hole, this hole, this hole, this all will be getting the ground. Okay. So what you can do now is, you can just connect your LED's ground pin or the negative pin here, right? For sure. I'm gonna explain the connection one more time. No need to worry about that. All right. So so this is the connection. Now let me again explain it to you how our connection is working. So see the code. We have taken two digital output pins, okay, in order to connect with two LEDs, right? So we are controlling two LEDs. Now to interface a LED, we need two terminal, that is positive and negative, okay? And our positive terminal has to be connected with the digital pin. But as I have told you that we need to interface one resistance, so that we make sure our LED is not burned out, right? So where that resistance to put? So we have to put that resistance in between the positive terminal of the LED and the digital input pin. All right. This is clear. Always. This is clear, right? You got this. Yeah. Amazing. So if you are clear about that, now let's see the connections. I have just connected the pin number 3 with the LED, red LED, right? So here, my positive terminal of this red LED is connected with this resistor, and this resistor's another end is connected with the connecting wire with going towards the digital pin 3. All right. Next, for the green LED, I have taken the digital pin 4, and the plus or the positive terminal is connected with the resistance, and this resistance another end is connected with the connecting wire, and this connecting wire is going to the Arduino's pin number digital pin number 4. Got it? That's it. And as we know, in order to interface a LED, we need to give the positive as well as the negative connections, right? So for the negative or the ground connection, what I did is I just take this ground wire common and I put it in this, you know, vertically connected, or you can say all these connections are vertically connected, right? So they are parallelly connected. So I have put my ground wire there. So every hole of this breadboard is having negative connection or ground connection, right? So the positive connection we may need to give differently, but the ground connection we can make it common. Okay, in every circuit, you have to make sure that you have to keep it in your mind. So what I did is I connect the ground connection of each LED to this negative terminal. Okay. So this is how our LEDs interface. Now it's time and moment for the truth whether it works or not. So I will just click on start the simulation. Let's see our simulations works or not. All right. Let me check it. Either it's because I have taken uh, all right, so I think the resistance value is more than we thought of. Okay, just give me a second, guys. All right, let's set up again. So we are having our breadboard of, all right, we are having two LEDs, one red, one green. This is our green LED. This is our red LED, right? Now this is our digital pin 4, and it's going to our green LED's positive terminal, right? This is our digital pin 3. This is going towards the digital positive terminal of the red LED. Now we are taking the negative terminal, putting it here, putting it here, taking the ground. Let me check if it works or not. Okay. Why it's not working or it's glowing? Wow, that's unexpected. Like it should work. Let me just change it. Let me reset the connection. Don't know why it's happening. Uh, any idea, guys, why it's not working? Okay, yeah, that may happen. So let's check it again. It's compiling first. Okay, okay, it's compiling first. All right, got it. Hmm. So let's do it again. Oops, oops. This issue happens with the work LED, LED. Let it. One is red, one is green, one is breadboard, right? That's that. Here, let it here. Then let it connect positive terminal with the negative terminal. Connect that is the three. Then let's take it common in the ground. Okay. Okay, let's see. Let it be compiling. So it doesn't take this much time in real hardware. It's still compiling. I think it's better we can do it in our real Arduino. So it will be better for you to understand, right? So let me just interface it with the Arduino cable. Okay. So I'm just connecting my real Arduino with it. Let me find another LED. Got it. So, okay, guys. So here my another LED is. It doesn't take this much time. It's working. Yeah, it should work. Basically, I feel there is something happening with VoPV or maybe my internet, but it gonna work, right? The connection is perfect. Nothing wrong in this connection. I feel just all right. Server load is heavy. Yeah, definitely. I think you all are doing at the same time. That's why you have crashed the VoPV software also. I think I have deleted that off screen. Conspiracy. Okay, guys. As our workflow is not working properly, let's try it on real hardware, and I hope that gonna work pretty good. So here I'm having breadboard. I have taken two LEDs, and also I have taken two uh, resistors also to showcase you. So, oops, deleted that. All right. So I think I can just. Yeah, it's fine. I will do. Uh, just turn off. Yeah, fine. So I think it's you can see right. So this is the breadboard. I'm having two LEDs. This is my positive terminal, right? This is my positive terminal, right? So here's my first LED, okay, and here is my second LED. This is the positive terminal. This is the negative. All right. And just like that, we will fold our 1 ohm resistance, right? I will just keep it. one here and another in this. Yeah, all right. And I will take another resistance for this LED. Okay. So, all right. So yeah, now I think you can see it, right? So here what I do, whatever I did in the work I did the same thing here. In my positive terminal, I used the resistance. Then I can take the connection from here. Similar to this LED. Now what I will do is I will use my jumper wires in order to connect with my Arduino. So here this is I'm taking the first red LED, then I'm taking for the uh, blue LED for say I don't know which color LED it is, but definitely. Now I have to connect it with the digital pin of 4 and 3, right? So for say if I'm taking one as 3, another as 4, next I have to where are the cables? Yeah, we got. So this is how the cables looks like, right? It looks like a rainbow. I'm taking two cables, three cables. All right. Okay, guys. So I think it's all right. Can you see? I think now you can see it clearly, right? The microcontroller board and my, Arduino, right? So here is my Arduino. I have connected the pin number two, sorry, the 3 and 4 with this first LED and second LED, right? So my logic is when first LED is turning on, the second one should be turned off. And when the second one is turning on, the first one should be turned off, right? So I will take I have interfaced the positive terminals. Now I will just take it, take the negative terminal, okay, and I will connect it to this portion, this common ground, which I will be taking, right, from here. So I'm having the ground, I'm taking it common, and I'm just, inserting it in this hole. So right now, this is the common ground, and this LED is taking ground from here, and this is taking ground from here, right? And this is how the positive terminals are connected with the digital pin 3 and 4. Got it? Now let's try to I guess you can see. I think server is busy. It's showing okay. Digital capture, yeah, display capture, right? So I think now you can see my Pictoblox screen, right? Now what I will do is I can directly, first I have to connect my board. So this is my device or this is my Arduino board which is showing here. I just have to click connect. Now my Arduino board is connected with the Pictoblox, right? Now I'm having this code. Just I have to click upload the code and it's building it, right? Done. Yeah, ground means earthing. Yeah, both are same terms, or you can just understand it as uh, negative terminal. Oh, you can see it's working. The first LED is turned on, the second LED is turned on, the first is turned off, right? So they are glowing alternatively, right? Here I'm not having that green and red LED, but you can understand, right? The logic that one is turning on, the another one is turned off for 5 seconds, right? So it will count for 5 seconds and then it will turn off and this will turn on. Okay. All right, guys. So this is about it, and this should work in that simulation also. Although I think the workfree software is having some issue, that's why it's not showing proper output. All right. Uh, now. I think we have did some mistake. That is, we should also include a delay here, right? So let's decrease our delay for say 2 seconds and then re-upload our code. Yes, 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 exactly. So now see 2 seconds, then it's on, it's glowing, then this glowing, then this glowing. Okay. So what mistake we did in our previous code is we have included the delay here, but here we haven't, imposed that delay. So what happened here? Uh, okay. Let me just explain it to you. What happened, right? So let me show you the transition. Okay. Yeah. Can you see the screen? So what was happening previously was that we haven't used delay here. Okay. So what was happening that once this part is executed and 5 seconds, then it's changed. Okay. But the digital pin were fixed on this position where our digital pin 4 is high. Okay. It's not changing because we haven't included delay here. Right. So once we included delay here, then our program starts working fine, as you can see. Right. So as you can see, it's working fine now. Right. So yeah. All right. So this is how we can, integrate two, what do you say, LEDs together. And although we are out of time, so I think next class we will be discussing about how can we interface push button, and I will be showing you how to interface push button in Arduino. And that's all about today's session, guys. I hope you have understood. And also, I want to tell you something that, as you can see this now. Now our LED is stuck on the position where it's says the digital pin is high. All right. Why? Because we have used this block. Okay. Let me just turn off the screen video capture device. Yeah. Now you can see that in the blocks, we have used this one that repeat for 3 times. So this thing, today's lecture unlocked flickering Diwali lights. Yeah, exactly. So see, previously you only know that Diwali lights looks amazing, but you can now, build your own Diwali lights for your house decoration on Diwali, right? So you can tell your mother that, Mom, you don't need to go to market and buy the Diwali lights. I can build it by myself, right? Amazing. So here you can see that here we use this repeat option where it will just execute this particular blocks for 3 times and then it will stop executing, right? So it will repeat only for 3 times. But on the place of this repeat, if I put, this forever loop, and then if I check it, let's upload it. Let's see. Yeah, done. Now, see, it's turning on, it's turned off. It's turning on, it's turned off. It's turning on, it's turned off, right? And it will be work. Oh, I'm so sorry. I think I have to show my video. Yeah, as you can see, now it's working continuously. It's not stopping. It's not stopping about after, yeah. Now you can see that it's working continuously. It's not stopping after executing 2 times or 3 times, right? So now it will continuously work until and unless I plug in or just plug out the USB plug or just remove the power supply of it. Or I just, as I talk about how the physically I turn on, right? So it basically means I just do like this. Okay. So if I'm doing like this turned off. Okay. So this is I mean about physically turning off it. And that's why we need a switch through which we can control it. So whenever we click the switch, it will turn on, and which whenever we, uh, you know, you know, again click the switch, it's turn off, right? So we are having different kind of switch, but the most common switch is our push button. So in the next class, we will start with the push button, and then we will move forward actuators and how to control servo motors, how to control other sensors using uh, block-based coding. And after we complete that, we're gonna understand how the C++ coding work, so that you will be able to start working with C++ directly, or Arduino's programming language directly. All right, guys. So that's it for today's session, and I think you understood. And regarding that work fee problem, I guess that was a server issue because our hardware is working. So definitely the simulation must work. So your today's task will be to execute that simulation after doing the proper codes which we have seen, right? And similarly, today's assessment also will be having one question that will be about hands-on, right? And the question will be this. You have to try it by yourself and you have to submit the screenshot. All right. And as per that, you will be getting the score. Okay. So hats off to those people who are watching, till the end. Okay. You are really doing great and you are in the right path. So just never give up and stay consistent. You're going to learn a lot of things, right? So now, let me see if you are having any questions. So you can ask me, all right, in the chat box. First, let me see. Are you guys, have you understood all those things which we have discussed today? Let me see in the chat box. Show the thumbs up, guys. Come on, show the thumbs up. Got it, sir. Salute. Amazing, amazing, guys. That's what kind of energy we need. Yeah. So, how to know our scores? I think the score has been released. You will get a mail. Check your mail. The mail which you have used for, you know, giving the test. You will get your scores. Okay. OP. Yeah. That's kind of response we want. And really, guys, the feedback which I got from yesterday's session, you know, that means a lot for me. That's amazing. Love you guys. Next question. Yeah, can we see it without using resistor? Will it damage the board? Okay, let's try. Let's try. So I remove all the connections. I have again connected. So this is my ground. I have to connect it to the ground. Uh, if I destroy my board, who gonna give me the board? I'm not even charging for these classes. I will be not able to afford another one. So pray for me. Okay, I have to first remove the resistance, right? So resistance is removed. I remove this resistance. Now let's check to the pin number 3 and 4. Okay. Oh, yeah. The first thing you can observe is this LED is glowing much brighter, right? So without resistance, it's glowing brighter, which means looking as array, yaar, don't make me blush. Okay. Yeah, so you can see the LED is blinking much brighter. But it's not gonna blow it up, but definitely it's sometimes what happens when you use external power supply. For example, if you are having 13 LEDs, right? So this microcontroller will be not able to power all the 13 LEDs. On that case, you need to have an external power supply. For example, you must have a battery which will be powering this LED. Okay. So on that case, it's become very necessary that you must include a resistance. Otherwise, this microcontroller may provide you a stable output, right? May provide you a stable output voltage, but a battery never provides you a stable output. Sometimes it's higher, sometimes it's lower. So you need to interface resistance. And also, if your, for example, your battery is more powerful, like it's giving you 7 voltage, but you just need 5 volt for running this LED, you need to use resistance in order to, provide less voltage to the LED. So that's why LED is very important. And including LED while interfacing with Arduino only is a good habit we should have. All right, guys. Yeah, thanks, guys. So that's all about today. Oh, so that's all about today, guys. See you in the next class, and bye. Goodbye. Good night, guys.